All right, welcome back. This is our AI Practitioner Exam analysis. We're going to go over some questions, some answers, and analyze why some of the answers are correct or incorrect. But before that, remember to like, subscribe, and share this with anyone you know who's going to be taking the AI Practitioner Exam. So let's get started. A retail company is looking to enable its business analysts to leverage machine learning without needing extensive coding skills. The team wants to solve key business challenges such as demand forecasting and customer segmentation by using a tool that offers a visual point-and-click interface, allowing them to build, train, and deploy machine learning models easily. To ensure the right solution is chosen, the company is evaluating AWS services that provide this capability. So the answer is SageMaker Canvas. So why is this correct? So SageMaker Canvas is designed to specifically let non-technical users like business analysts build machine learning models through no-code, point-and-click interfaces. So it lets teams access and import data from over 50 sources. Think of S3 as one of them, right? And it does this via SageMaker Data Wrangler. And you can prepare and transform data. You can use auto machine learning, which is the SageMaker autopilot, to build and train models, and you can deploy models and generate predictions, all without writing a single line of code. So certain things it could be used for would include customer segmentation, forecasting for sales, churn prediction, and fraud detection. So why are the other answers incorrect? SageMaker Data Wrangler. So this is used for data prep, not building or deploying models without code. It assists SageMaker Canvas, but it's not a no-code solution. SageMaker Clarify. So this focuses on bias detection and model explainability, not for building or deploying models via a visual interface. And then SageMaker Model Dashboard. So this is a monitoring and management tool for existing models. It tracks deployment status, endpoint usage, and whatnot, but it doesn't build or train models. Okay. All right. Next question. Technology firm is developing an AI-driven solution for automating business processes and needs to define or design effective prompts for its generative AI model. The model is tasked with solving complex multi-step problems such as generating detailed business reports or creating process workflows. To improve the model's performance, the team is exploring prompt engineering techniques that can help simplify these tasks by breaking them down into smaller, manageable parts. Chain of thought prompting. So what is chain of thought prompting? Why is this correct? So chain of thought is a prompt engineering technique that guides a Gen AI model to reason step by step, mimicking human problem solving. So it's especially effective for multi-step tasks like business report generation, process automation, or any complex calculations. So instead of giving the answer directly, the model is encouraged to think aloud, logically progress through smaller components of the task, and deliver the outcomes. So why are the other answers incorrect? So zero shot. So zero shot provides no examples of how to perform the task. While it's efficient, it's not optimal for complex or multi-step reasoning problems. Few shot prompting. All right, this is a tempting one. But few shot provides a few examples to guide the model. It provides output in many tasks, but it doesn't inherently break down a problem into logical substeps. And then negative prompting. So this is telling a model what to avoid. So it says, don't mention whatever brand you're going against if you're in an advertising space or a marketing space. It's useful for refining output, not for structuring complex logic. All right. Next question. A financial services company is building a machine learning model to predict loan defaults, but the data science team is struggling to find the right balance between model complexity and accuracy. They're aware of the bias-variance tradeoff, as understanding this tradeoff is critical for optimizing the model's performance and ensuring it generalizes well. The answer: the bias versus variance tradeoff refers to the challenge of balancing the error due to the model's complexity, to the variance, and the error due to incorrect assumptions in the model, which is the bias. Where high bias can cause underfitting and high variance can cause overfitting. So why is this correct? All right. So this reflects core principles in the bias variance trade-off, right? Bias is the error due to oversimplistic assumptions in the learning algorithm. So high bias can miss relevant patterns. Okay, so this underfits it. And then variance is the error due to excessive model complexity. So it makes the model overly sensitive to training data. So high variance can cause the model to perform well on training data, but poorly on unseen data. This is overfitting. So the goal is to find that sweet spot where the total error, which is that bias and variance and an irreducible error rate, is minimized. Okay, so why are the other answers incorrect? Okay, the high bias leads to underfitting. High bias variance trade-off refers to the balance between underfitting and overfitting. Okay, so this reverses the concepts. So high bias leads to underfitting, not overfitting. All right. The bias versus variance trade-off is used to improve model performance by increasing. No, so this is incorrect. Raising both increases the total error. Okay. And then the bias variance model trade-off involves choosing between a model with high complexity. So this also swaps the definition. So high complexity leads to high variance and while simpler models typically have higher bias. All right. Okay. Next question. Okay, a healthcare company has deployed a machine learning model using Amazon SageMaker to predict patient health outcomes based on various clinical parameters. A data analyst at the company inputs new patient data such as age, blood pressure, and cholesterol levels into the SageMaker model to receive a prediction on the likelihood of cardiovascular event. The analyst needs to understand the specific term for this process where the trained model uses its learned patterns to provide a prediction or output based on new input data. Okay, so let me see. Okay, so the process is called inference. This is where the model uses its trained parameters to generate a prediction or output based on new input data provided by the user. So why is this correct? Okay, so inference is the correct term. It refers to the stage where a trained machine learning model is deployed to make predictions or general outputs based on new input data. During inference, the model uses the patterns and relationships it learned during training to provide accurate and meaningful results. In this scenario, the user sends input data to the SageMaker model, which then performs inference to generate the corresponding output or prediction. Why are the other options incorrect? So training. Why is this process known as training? Okay, so training is the process of teaching a machine learning model to recognize patterns by adjusting its internal parameters based on a labeled data set. This scenario describes what the scenario describes does not involve modifying the model's parameters. It only involves using trained model to make predictions. Okay, recognize that distinction. All right, validation. Validation. So validation is used to evaluate the fine tune in the model during the training process. So it checks the performance on a validation set. This is after the fact, right? And since this scenario involves using the model to predict outcomes from new input data rather than evaluating or fine tuning it, validation is not correct. And then testing. Okay, so testing is the final evaluation phase where the model's performance is assessed on unseen test data after training is complete. The scenario in the question focuses on generating predictions from an already trained model, not testing its performance. All right. Next question. A consulting firm is considering adopting Amazon Q Business to help its teams automate workflows, generate business insights, and streamline decision-making. To ensure smooth integration with their current AWS infrastructure, the firm's IT department needs to understand which underlying AWS service powers Amazon Q Business. Okay, so the answer is going to be Amazon Bedrock. All right. So why is this correct? So Q Business is a fully managed Gen AI powered assistant that can be configured to answer questions, provide summaries, generate content, and complete tasks based on enterprise data. And Q Business is backed by Bedrock, which provides the foundation models and the Gen AI capabilities that enable Q Business to understand and respond to user queries intelligently. So why are the other answers incorrect? Okay, let's see. Kendra. Okay, so Kendra is an intelligent search service using natural language processing, but it's not the foundation service for Q Business. And then SageMaker Jumpstart. So this is a machine learning hub with foundation models and pre-built machine learning solutions. It's not what powers Q Business. And then Q Apps. Okay, so this is a capability within Q Business for users to create Gen AI powered apps, not the underlying service that powers Q Business. All right. Next question. All right, which of the following scenarios best illustrates the difference between exposure and prompt injection in the context of AI models? All right. Oh man, I forgot the images for this. Please excuse me. We're going to move on. Okay. So basically, I'll just explain what prompt injection is. All right. So prompt injection in this situation refers to influencing outputs by embedding specific instructions within prompts themselves. And then exposure refers to the risk of exposing sensitive or confidential information during training or inference. Okay. So recognize what those are trying to do, and you'll get this on the exam. My apologies. But we'll move on to the next one, since it's hard to do this without the actual image that corresponds. All right. Okay. Match the following SageMaker services to the respective use cases. All right. So it's going to be, all right. So the correct answer is going to be this one. All right. C. All right. So this means SageMaker Data Wrangler offers 300 pre-configured data transformations to prepare data for machine learning. And then B, SageMaker Canvas is a no-code service with an intuitive point-and-click interface. And then ground truth is harnessing human input across the machine learning lifecycle to improve the accuracy and relevancy of models. All right. Okay, so the other answers are all matching combinations that contradict the specific capabilities, right? So the purpose of each SageMaker service is pretty much good to go, especially if you can use process of elimination, right? Especially if you understand if you understood Data Wrangler and ground truth, then you can understand Canvas, or Canvas and Data Wrangler, then you can understand ground truth, right? Use that process of elimination for questions like this. All right. Okay, next question. A retail company is building multiple machine learning models using Amazon SageMaker to optimize inventory management and customer recommendations. The data science team wants to collaborate more effectively by sharing and reusing features without duplicating data across different models. They're looking for a service within SageMaker that allows them to maintain a centralized catalog of features, ensuring consistency and efficiency in their machine learning workflows. So that's going to be SageMaker Feature Store. All right. So SageMaker Feature Store is the fully managed purpose-built repo to store, share, and manage features for machine learning models, right? So it does everything the company needs. That can be centralized feature catalog that the teams can discover and reuse. And it'll eliminate feature duplication across different models. It'll tag and index feature groups for easier discovery through SageMaker Studio. It'll enable confident feature reuse and avoid duplication of pipelines. And it integrates with Amazon or AWS Glue data catalog and supports SQL queries through Athena. All right, so why are the other answers incorrect? All right, so Data Wrangler is used for data preparation and feature engineering, not for storing or sharing features. Model dashboard is a portal for viewing and managing models. And then Clarify helps identify bias and explain model predictions, not for feature management. All right. Next question. Okay. A media analytics company utilizes Bedrock to run inferences with its generative AI models to analyze large volumes of user-generated content and provide insights to its clients. The company frequently processes numerous inference requests and is looking for a way to minimize the costs associated with running these inferences while still maintaining the required level of service. Given that the company can tolerate some delays in receiving responses, it seeks a cost-effective inference method that optimizes resource usage without sacrificing too much on turnaround. All right. How do you do this? Okay. The company should use batch inference, thereby, let me highlight that. Okay. Companies should use batch inference, thereby allowing it to run multiple inference requests in a single batch. All right, so this is correct because batch inference is the most cost-effective choice. All right, Bedrock offers batch inference at 50% off of on-demand pricing. All right, it allows processing multiple inference requests asynchronously in a single batch. It's ideal when immediate responses are not required, right? So the company can tolerate delays, and it's more efficient at resource utilization by handling multiple requests simultaneously. And it minimizes computation expenses through bulk processing. All right, so why are the other answers incorrect? All right, so real-time and serverless, okay? So these options apply to SageMaker, not Bedrock, which only offers on-demand or batch inference, okay? So you have to know these tools. And then on-demand inference, okay? While it's flexible, it's more costly when used frequently, and it doesn't have the benefit from the bulk processing save costs the bulk processing cost savings of batch inference. All right. Okay. All right. Next question. A healthcare company is integrating AWS AI services to build models for patient data analysis and personalized treatment recommendations. The company is exploring the AI service cards, and it would like to know more about use cases relevant to the AI service cards. Given the context, what would you identify as the primary purpose of AI service cards? To offer transparency and information about the intended use, limitations, and potential impacts of AI services, helping users implement responsible AI practices. All right. So AI service cards are designed to enhance transparency and advance responsible AI by providing users with crucial information about the intended use cases of AI, the limitations or potential constraints, the potential impacts of using the services, and implementation guidance. This helps users make informed decisions and implement responsible AI practices, so you can understand the implications of using the services in their specific context. All right, so why are the other answers incorrect? All right, a platform for sharing AI models? No. Okay, AI service cards are informational resources, not platforms for community sharing. And then marketplace for purchasing third-party AI services? No. So this is not the purpose. That is not it. Feature store might be close, but there is a marketplace for different models, but that is not what service cards are for. And then provide detailed documentation for setting this up? No. So that is an important thing to have. And service cards are service cards are not that, right? Service cards are about transparency and responsible AI, not technical setup. All right. That's where you would just go to the AWS documentation. All right, next question. All right. A retail company is exploring machine learning to improve customer segmentation and discover hidden patterns in sales data. The data science team is particularly interested in using unsupervised learning to analyze large volumes of unlabeled customer and product data to identify trends and groupings without predefined categories. To determine the best approach, they need to understand which methods fall under unsupervised learning. All right, so that's going to be dimensionality reduction and clustering. All right, so why are these correct? Okay, so unsupervised learning algorithms train on unlabeled data and establish meaningful connections between unknown inputs. All right, so clustering. So this groups data inputs into categories as a whole. It's perfect for customer segmentation by identifying different types of customers based on behavior patterns without predefined labels. And then dimensionality reduction reduces the number of features in the data set, often used to pre-process data, and reduce complexity while preserving important information. All right. So why are the other answers incorrect? All right. So decision tree. So this is a supervised learning technique that requires labeled data to make predictions using if-else structures. Okay. Remember that data types. All right. Unsupervised versus supervised. I know which one uses it. All right. Sentiment analysis. Okay. This is a semi-supervised learning that combines both labeled and unlabeled data. All right. And then remember that unsupervised, right? That's the key. And then where are we at? And neural network. Okay. So this is a supervised learning technique that requires labeled inputs and outputs for training. All right. All right. Next question. A financial services company is exploring the use of AI to improve fraud detection and automated credit risk assessments. The data science team is evaluating whether to use traditional machine learning techniques or deep learning, depending on the complexity of the tasks and the size of the data involved. Understanding the key differences between deep learning and traditional machine learning will help the team choose the right approach. So how would you do this? All right, it's going to be these two. In traditional machine learning, data scientists manually determines the set of relevant features that the software must analyze, whereas in deep learning, the data scientist gives only raw data to the software, and the deep learning network, which is a network, okay, derives the features by itself, right? And then deep learning is a subset of machine learning that uses neural networks with many layers to learn from large amounts of data, while traditional machine learning often requires feature extraction and can use various methods such as decision trees or support vector machines. All right, so why are these important and why are these correct? Okay, so traditional machine learning requires manual feature engineering, where data science do all the relevant features, and then the deep learning can work with the raw data and automatically learn. All right, and then deep learning uses the neural networks with the multiple layers, hence the deep, right, to automatically learn representations from the large data sets. So Traditional machine learning uses various algorithms with manual feature extraction. All right. So why are the other ones incorrect? All right. Do not do data pre-processing. Okay. So both can benefit from pre-processing, but deep learning can better handle raw data. Okay. And then, okay, traditional machine learning is only used for supervised learning tasks. Uh, all right. So both can be used for supervised, unsupervised, and reinforcement learning tasks. And then deep learning models are always faster to train than traditional. No. Okay, so deep learning models are typically computationally intensive and take longer to train. And so you need to know the characteristics of these as well. All right. And then next question. All right. All right. A biotech company is building machine learning models using SageMaker to analyze large genomic data sets for research purposes. The team is considering Amazon SageMaker asynchronous inference to handle these predictions efficiently. To ensure that this deployment model aligns with their requirements, they need to understand which use cases are best suited for asynchronous inference. All right. So requests with large payload sizes up to 1 GB and long processing times, right? So why is this correct? So SageMaker asynchronous inference is specifically designed for large payload sizes, up to 1 gig, and it's perfect for genome data sets, which are typically very large. And it takes long processing times, right? Up to 1 hour, right? So this is ideal for those complex genomic analysis that requires extensive computation. And then there's near real-time latency requirements. So this provides reasonable response times without requiring immediate responses, and cost optimization, right? So this automatically scales to 0 when no requests are being processed. So you only pay when processing. All right. And why the other answer is incorrect? Okay, for persistent real-time endpoints. All right. So these are for SageMaker real-time hosting services, not asynchronous inference. And then predictions for an entire data set. Okay, so this would be for SageMaker batch transformation, not asynchronous. And then for workloads that can tolerate cold starts. Okay, this describes SageMaker serverless, not asynchronous. So know those definitions of the services and you'll do much better. Okay. All right. Next question. All right. A logistics company is building machine learning models using SageMaker to predict delivery times and optimize routes. The data science team needs to clean and pre-process large data sets efficiently, but wants to minimize manual coding to speed up development. They are looking for a SageMaker service that offers built-in data transformations, allowing them to quickly prepare the data without coding. All right. So I mean, this is easy from all this. Preparing Data Wrangler. All right. So why is this correct? This is a perfect solution. Well, all right. What does this do? It reduces data prep time from weeks to minutes. It provides hundreds of built-in data transformations without requiring any code. It offers a single visual interface for entire data prep workflow. It supports data selection, cleansing, exploration, visualization, and processing at scale. And it uses pre-configured PySpark-based transformations for common tasks like flattening JSON, deleting duplicates, imputing missing data, and one-hot encoding, right? And time series transformations too. All right, so why are these other answers incorrect? Clarify. This is used for identifying potential bias in data and models, not for data prep. And then ground truth. This is for human-in-the-loop capabilities for data annotation and model evaluation. And then feature store. So this is a repo for storing and sharing machine learning features. Okay. See how they try to confuse you? Because you know SageMaker is useful and it's used for a lot of things and you would use these. Yeah. So just pay attention, read the question closely. Next question. A legal services company is implementing AI solutions using Amazon Bedrock to improve document analysis and automate responses to client queries. The team is exploring two approaches: RAG, retrieval augmented generation, and agents. Since understanding the key differences between these approaches will help the company decide which method best suits their AI strategy for delivering precise and context-aware responses. All right, so here's the correct answer. All right, RAG refers to querying and retrieving information from a data source to augment a generated response to a prompt, whereas agent refers to an application that carries out orchestrations through cyclically interpreting inputs and producing outputs by using a foundation model. All right. So RAG, this answers it accurately. is RAG talks about the queries and retrieving information. It can help to augment and enrich the model response. And an agent is an application that carries out the orchestration, right? So it's capable of executing the complex workflows. That answers it. Why are the other ones incorrect? The other ones, all right, I'll boil this down, right? The other ones either incorrectly assign the definitions to the wrong concepts, like they reverse it, or they incorrectly state that both RAG and agent serve the same purpose. Okay, so both RAG and agent carry out orchestrations, right? An agent refers to querying, flipped it. Both RAG and agent refer to query. See what I'm saying? It's man. All right, that's why you have to pass this and go straight for the machine learning associate. All right. All right, next question. A financial services company is developing a machine learning model to predict credit risk and optimize loan approvals. The data science team is preparing the data set for model development and needs to understand how to properly split the data into training, validation, and test sets. Each of these sets serves a different purpose in ensuring the model's accuracy and generalization. Understanding the key differences between a training set, data validation set, and test set will help the team implement an effective model evaluation strategy. All right. Okay, this is the correct answer. Training set is used for training the model. Validation set is used for tuning hyperparameters and model selection. And the test set is used for evaluating the final model performance. Why is this correct? I mean, it listed them correctly. That's the short answer, right? But yes, training set is to train and train the algorithm. So looking for that, okay? That's going to be the easiest one. Process of elimination. Validation is used for hyperparameter tuning and model selection. Test set is used for final performance evaluation. All right. And we've covered this in most of these sections. And again, all the other options incorrectly assign the purpose of each data set or mix up their roles, right? So this one says training set is used for evaluating. No, that would be the test set, right? That's the evaluation. Okay. Training set is used for tuning. Nope, that would be validation, right? Training set, validation, and tests all serve the same purpose. All right, that mixes them up. Okay? Okay. We'll get to the next question. All right. A healthcare company is developing a machine learning model to predict patient outcomes based on medical data. To ensure the model generalizes well, the company needs to understand the balance between underfitting and overfitting and how to address these issues. Correct answer. Underfit models experience high bias, whereas overfit models experience high variance. All right. So why is this correct? So an underfit or high bias model is too simple and cannot capture the relationship between the input and output. It gives inaccurate results for both training and test data due to overly simplistic assumptions. And then overfitting or high variance is too complex. It memorizes training data, but fails to generalize and apply it, right? So it gives accurate results for training, but poor results for test data. So it's due to the sensitivity to small data fluctuations. The goal is to find that sweet spot between underfitting and overfitting for optimal model performance. So for this one, again, all the other combinations assign bias and variance levels incorrectly. Low bias, that means it would be very, very well fit, right? Whereas overfit, yeah, see, it just mixes this up. And if you read this too much, you're gonna get like it gives you half of it overfit high variance, overfit high variance. Oh, incorrect here. So it gives you part of it is correct, part of it's incorrect, or both of them are incorrect. Okay. All right, next question. A healthcare company is developing a machine learning model to classify medical conditions based on patient data. The data science team needs to evaluate the model's performance to ensure that it makes correct predictions, particularly for critical diagnoses. To do so, the team is considering various performance metrics commonly used for classification systems. So, precision, recall, and F1 score. All right. These are the standard performance metrics for classification systems, right? Precision. This measures the accuracy of positive predictions. So true positives, and it's critical for minimizing false alarm. Recall. This measures the ability to identify all positive instances, right? And then F1 score. This is the harmonic mean of precision and recall, providing a single balanced metric. It's essential for the overall classification performance. These are important for healthcare for evaluating diagnostic accuracy. All right, so other answers. Why are they incorrect? Okay, throughput, latency, and time. Okay, that's not it. These are system performance metrics. And then bias and variance, we talked about this. These are model complexity concepts. And then mean absolute error, root mean squared error, and R squared. Okay, these are regression metrics, not classification. Okay. Next question. A video streaming company is developing the machine learning models to recommend content and analyze user interactions. The data science team needs to understand the specific capabilities of convolutional neural networks, CNNs, and recurrent neural networks, RNNs. What is the correct answer? All right. So, CNNs are used for single image analysis, while RNNs are used for video analysis. Why is this correct? So CNNs are designed for grid-like data, like images. They can automatically learn spatial hierarchies of features from input images, making them perfect for single image analysis. And then RNNs are designed for sequential data, where order matters. They handle time series data and temporal dependencies, making them ideal for video analysis where frames follow a sequence. All of their combinations incorrectly assign it, right? So see this? Both, right? Both are used for image. Both are used for video. And this one reverses it. Okay. Okay. All right. Next question. All right. A hiring platform is developing a machine learning model to help companies screen job candidates. During testing, the data science team notices that the model seems to favor certain demographic groups over others. The team suspects that the training data may reflect historical biases from previous hiring practices, leading to biased predictions. To address this issue, the team wants to understand how human bias can influence machine learning outcomes. So, that's the correct answer. A data scientist selects features for a machine learning model based on their personal beliefs about which attributes are important, leading to a biased model. So, this scenario exemplifies the human bias, right? This is where the data scientist's personal beliefs influence the feature selection process, right? The human decision making directly impacts the model's development. The bias is introduced by human judgment rather than the data itself, and this leads to a biased model that reflects the scientist's preconceptions. All right. Why are the other ones incorrect? So, trained on historical hiring data. Okay. So, this represents algorithmic bias from bias training data, not human bias in the development process. Okay. And then, okay. So, machine learning algorithms predict customer churn based on historical data. Sorry, excuse me. This describes data skew due to temporal patterns, not human bias. Okay. And then data scientist selects features for machine learning model based on personal beliefs. This is a tempting one. Okay. Okay. Oh, I'm sorry. I picked the wrong one. Sorry. An automated translation service frequently makes errors. Okay. This is wild. This is wild. You could automatically mark this incorrect. So this is a translation error, right? So this represents a model limitations in handling a language nuance, not human bias. Okay, we're not trying to tell whether human bias is right or wrong. We're trying to see what it is in regard to this question. Okay. Next question. A retail company is developing machine learning models to analyze customer behavior and optimize inventory management. The data science team is working with both structured data as well as unstructured data and needs to understand how these two types of data differ in terms of how they are processed and used in machine learning models. Understanding this is the key difference that will help the team select the right algorithms and pre-processing methods. This is the answer. Okay, so structured data is organized in a predefined manner, often in rows and columns, making it easy to search and analyze, while unstructured data lacks a specific format and includes data like text, images, and videos. All right, so why is this correct? All right, so this pretty much labels out what this is, okay, and why it's correct. Structured data, organized, predefined, easy to search, analyze. You have to understand that, right? And it says it in the question. So it's easily found in databases and spreadsheets. Some good examples would be like customer records, or sales transactions, or inventory data, right? It's asking that question. All right. Unstructured data. This is no specific file format. This could be diverse data types like text, images, videos, whatever. It's more complex to process, but it contains a lot of information. So an example of this might be like a customer review, social media posts, or product images. All right. Why are the other ones incorrect? Um, okay, structured data. This is reversed. Structured data is typically free formed. I mean, just read that. All right. Structured data includes data like text, images. This is reversed. All right. So this is two portions of the reversal, right? And then structured data is typically used for training machine learning models, while unstructured is used for storing information without any. All right. I mean, that is just incorrect, right? So both types of data can be used for machine learning and various analytical purposes, right? Um, yeah, that's just mislabeling. Okay. Okay. Next question. Which security discipline in the Gen AI security scoping matrix focuses on identifying potential threats to Gen AI solutions and recommending mitigation? Risk management. All right. Risk management. So it specifically involves identifying potential threats to Gen AI, recommending mitigations for those identified risks, conducting risk assessments and threat modeling, and then addressing unique risks associated with Gen AI workloads, right? So this is essential for understanding and addressing the security challenges specific to Gen AI implementations. All right, so why are the other ones incorrect? Legal and privacy. All right, this is a tempting one. So this focuses on policies, procedures, and reporting specific to Gen AI, not necessarily the risk. All right, and threats. All right. Oh, I'm sorry. No, that's governance and policy. My apologies. Um, Legal and privacy addresses regulatory, legal, and privacy requirements. All right, so that is a subset of the overall safety features, but it's not specific to potential threats. Okay. And then resilience. So this involves designing solutions to maintain availability and meet the service level agreements. Okay. All right, next question. A social media company is planning to implement a large language model for content moderation to automatically flag inappropriate or harmful content. To ensure the model is fair and does not show bias or discrimination against specific groups or individuals, the company needs to evaluate the model's outputs regularly for potential bias. The team is considering different data sources for this evaluation, wants to choose an option that minimizes administrative effort while providing reliable and comprehensive insights into any biases or discrimination present in the LLM's outputs. Okay, so the company should use benchmark data sets, which are pre-compiled, standardized data sets specifically designed to test for biases and discrimination in model outputs. Okay, so why is this correct? So this is optimal, right? This is pre-compiled and standard, so there's no need to create or curate data. This is specifically designed to test for various bias scenarios. It minimizes administrative effort, so it's ready to use without a bunch of setup. It provides a lot of coverage for potential bias types. It's easy to enable consistent evaluation across different contexts, and it's cost effective and quick to implement. Okay, boom. Um, let's see. Companies should use generated synthetic data. No. Okay. This requires a lot of resources and expertise to create accurate bias scenarios. Companies should use human monitored benchmarking where humans regulars. No, no, no. Okay, this requires a lot of administrative effort to coordinate and train the reviewers. And then the company should use randomly selected user general. No, that okay. So that requires manual curation, right? And it raises a lot of privacy. Okay, so it's just not going to be successful. Okay, next question. Okay, a retail company is exploring machine learning algorithms to improve its customer segmentation systems. The data science team is evaluating both k-means and k-nearest neighbors, KNN. So these algorithms, expanding these algorithms, but needs to understand the key differences between them, since understanding these distinctions will help the team choose the right algorithm for their specific tasks. What are they? Okay. So k-means is an unsupervised learning algorithm used for clustering data into groups, while KNN is a supervised learning algorithm used for classifying data points based on their proximity to labeled data groups or labeled examples. All right, so why is this correct? So k-means is unsupervised learning, clusters data points in distinct groups. It minimizes the variance within each of the clusters. No data labeling or labeled data is required. It's perfect for customer segmentation. And then KNN, K nearest neighbor, right? So that's supervised learning. It classifies new data points based on proximity to K nearest neighbors. And it requires labeled training data, and it's used for classification and regression. right, so why are the other ones incorrect? Let's see. K-means is a supervised learning algorithm. All right. This reverses which algorithm is which, supervised versus unsupervised. All right. K-means requires label data to perform clusters, while KNN does not use label data. Okay. So K-means doesn't require label data. KNN does require label data. You see where they're picking this apart? And then K-means is primarily used for regression, while KNN is used for reducing dimensionality. All right, K-means is not for regression, and KNN is not for dimensionality reduction. Okay. Next question. The company wants to implement safeguards for its Gen AI applications using Bedrock. Specifically, the company wants to filter undesirable and harmful content, as well as redact any PII, personally identifiable information, right? You're going to use guardrails, okay? Guardrails is specifically designed to do this. You can implement a lot of safeguards for Gen AI applications, right? What does this do? You can filter undesirable or harmful content based on responsible AI. You can redact PII or PHI or whatever to enhance privacy. You can control interactions between users and foundation models, and you can enhance content safety throughout the applications. So this directly addresses both the requirements, content filtering and PII redaction. All right, why are the other ones incorrect? So knowledge bases. So this is used with RAG or for RAG, or so it provides contextual information, not filtering. And then watermark. This is used with Titan image generator. All right, so anytime you see a deep fake, there you go. Continued pre-training in Bedrock. Okay, so this is used for model customization with domain-specific data. All right. And next question. All right. Oops. A financial services company relies on several independent software vendors, ISVs, for key operational applications and needs to maintain up-to-date compliance records to meet regulatory requirements. To streamline its compliance management process, the company wants to receive email notifications when ISV compliance reports like SOC 2 or ISO certifications become available, ensuring that its compliance team is promptly informed and can take necessary actions. What's the correct answer? Okay. So the company should use Artifact to facilitate on-demand access to AWS compliance reports and agreements, as well as allow users to receive notifications when compliance documents or reports, including ISV compliance reports, are available. All right. So Artifact is the solution, right? Because it provides access to compliance reports through the third-party reports tab, right? It offers notification subscriptions for new compliance documents. It supports email notifications when new reports or agreements become available. It's designed specifically for compliance documentation. And it includes ISV compliance, okay, for all vendors who sell through the marketplace. All right, so why are the other answers incorrect? This would be a good example of why you would do a process of elimination, especially if you already passed the SAA. All right, config monitors AWS resources for configurations, right? Doesn't do compliance reports. Trusted advisor. Okay. So trusted advisor provides AWS optimization recommendations, not compliance. And an audit manager. All right. This automates evidence collection. So if you have a screwed up EC2 and you've isolated it and you started to analyze it, this is where you get some good information or good usage from that resource. All right. Next question. A financial services company manages a machine learning model to assess loan eligibility for its customers. The company wants to migrate to the cloud and is looking at understanding the capabilities of the various SageMaker services to operationalize and manage its machine learning workflow. As an AI practitioner, what would you recommend the company as the best fit use case for the SageMaker Clarify service? Okay, so what is SageMaker Clarify? Boom. Use it to identify potential bias in data prep, allowing you to detect and measure bias in data sets and models to ensure fairness and transparency in machine learning. All right, so why is this correct? I mean, it's in one, you got to read, if you read this question, you should get it pretty good. Okay. Okay, so why is this correct? Okay. So Clarify is designed to identify and mitigate bias in machine learning models and data sets, right? You can detect potential bias during data prep without writing code. You can analyze both data and model predictions for fairness. You can generate bias reports to ensure transparency. You can ensure the models don't discriminate against specific groups, and you can ensure a trustworthy AI system, which is essential for a sensitive application like something like a loan eligibility. So this is critical for financial services where bias detection is crucial for regulatory compliance and ethical AI. All right. Why are the other ones incorrect? Hyperparameter tuning. So this is handled by SageMaker's built-in hyperparameter optimization. Mono clarify to monitor the quality. So this is handled by SageMaker Model Monitor. And then you SageMaker clarify to prepare models with no code. No. So this is handled by SageMaker Canvas. Okay. So if you're familiar with the names, you should understand these questions. At the names and what they do, just to be more specific. Okay. Okay, a financial services company is deploying a machine learning model using Bedrock to predict loan approval risks. The data science team needs to ensure that the model performs effectively before going into production. They're focused on understanding the correct practices and tools for model evaluation on Bedrock to ensure accuracy, fairness, and reliability in their predictions. So, what are the two answers here? All right. Automatic model evaluation provides model scores that are calculated using various statistical methods, such as BERT score and F1. And model evaluation is valuable for assessing qualitative aspects of the model, whereas automatic model evaluation is available for assessing quantitative aspects of the model. Okay, so why are these correct regarding Bedrock model evaluation? Okay, so automatic model evaluation, all right? So this provides the quantitative model scores and it uses BERT and F1, right? So this has objective, consistent measurement of the model performance. It uses built-in or custom prompt data sets, and it's good for quick evaluation of the model performance comparison. And then human model evaluation. Okay, so this provides a qualitative feedback on aspects like the coherence, the relevance, the accuracy. It uses human workers like employees or subject matter experts to assess overall quality of the model outputs. And you must use your own data set because there's no built-ins. All right, so why are the other ones incorrect? For human evaluation, no. So human evaluation requires your own data sets, not built-in ones. Read the question again, okay? Okay, and then, okay, okay, automatic model evaluation is for assessing qualitative, boom, that's it. All right, so this swaps the roles of the human and automatic. And then human model evaluation provides the model scores that are, okay. Okay, only automatic evaluation provides statistical scores like BERT and F1. So it swaps it. All right. Okay. Next question. Okay. A media company is considering using Gen AI to automate content creation for articles, videos, and marketing campaigns. The team wants to understand the underlying mechanics of Gen AI, particularly how models are able to create entirely new content or data such as text, images, and music based on patterns learned from existing data sets. This understanding will help the company determine how to integrate Gen AI into its creative workflows. So, proper answer does this by learning patterns from existing data and using algorithms to generate new content that mimics those patterns. Why is this correct? Okay, so Gen AI works by learning patterns from massive existing data sets during training. So it can use those sophisticated algorithms to understand the relationships and structures in the data. Then it can generate new content that mimics the learned patterns. And with that, it can create realistic and coherent outputs that align with the training data characteristics and apply learned knowledge to generate content for the new scenarios. So this lets it create realistic, contextually appropriate content for articles, videos, and marketing campaigns. All right, so why are the other ones incorrect? So randomly generating content. Okay, Gen AI doesn't work randomly. It uses learned patterns using predefined rules and templates. Okay, this describes rules-based systems, not Gen AI. And then manual traditional programming methods. So traditional programming requires manual coding. Gen AI learns automatically. Okay. All right. Next question. Consider the following AI model response. Ah, damn it. Okay. I forgot the image. Okay. All right. So I'll explain model hijacking and jailbreaking. I'll explain these. Sorry for not including the image on this one. All right. Hijacking is manipulating an AI system to serve malicious purposes or misbehave in an unintended way. Jailbreaking. This is bypassing built-in restrictions and safety measures to unlock restricted functionalities or generate prohibited content. Okay, so let's say if you had a useful response about learning programming and then divert into some unethical question about cheating or whatever like that, that would be the model being manipulative to serve a malicious purpose, right? And a jailbreaking would be turning like an innocent prompt about like poetry and then all of a sudden it'll provide information about disabling antivirus software, right? Or bypassing safety restrictions. Boom. All right, so other questions are not relevant because I don't have the photo here. My apologies. Okay. All right. A technology company is planning to implement machine learning to improve its product recommendation system and optimize supply chain management. The data science team is evaluating different types of machine learning approaches. Gaining a clear understanding of these types will help them choose the right strategy for model deployment. All right. The correct answer: supervised learning, unsupervised learning, deep learning. All right. So the main three types of machine learning are supervised learning. This uses labeled data to train models for prediction and classification. Unsupervised learning. This finds patterns in unlabeled data without specific targets. And then deep learning. This uses neural networks with multiple layers to learn complex patterns. These are the three fundamental categories that encompass most machine learning approaches. All right. So what are the other ones? Transfer learning, semi-supervised. All right, so what are the other ones? Okay, so transfer learning is a technique that uses pre-trained models, not a main type. It's a subtype. Semi-supervised learning, so this combines supervised and unsupervised approaches, not a main type. Self-supervised, another subset. Reinforcement learning, while it's important, it's considered a subset of machine learning approaches. All right, it's another one. All right, so if you know the mains and then the next level down and the next level down, then you'll be a lot better for it. All right, next question. Which of the following best describes the SageMaker Canvas ML tool? All right. It gives the ability to use machine learning to generate predictions without needing the ability to code. All right. SageMaker Canvas is specifically designed to enable no-code machine learning for business users. So you can generate predictions through a visual interface, chat with an LLM, access ready-to-use models, and build custom models. And you can democratize machine learning for non-technical users. So it's perfect for like a business analyst who needs machine learning capabilities without programming skills. So the other ones, what are the other questions? All right, so one-click end-to-end solution, that's Jumpstart. Fastest and easiest way to prepare data preparation. That'll be SageMaker Wrangler, or no, Data Wrangler, SageMaker Data Wrangler. Explain how features and contribute. That'll be clarify. To explains how input features contribute to the model predictions. Right? Clarify. Yeah. Okay. Anyways. All right. Next question. All right. A healthcare company is considering using Bedrock to develop AI solutions that handle sensitive patient data such as medical records and diagnostic information. Given the strict regulatory requirements in healthcare, the company needs to ensure that Bedrock provides robust data security and compliance features. The company is evaluating the platform's capabilities to safeguard data and meet compliance standards like HIPAA. All right. The company's data is not used to improve the base foundation models, and it is not shared with any model providers. Okay, why is this correct about Bedrock? All right, Bedrock has strong data security guarantees. This includes customer content. It's not used to improve base foundation models. It's not shared with any model providers. It's always encrypted in transit and at rest. The option to encrypt, there's also an option to encrypt with customer managed keys. Private link is available for private connectivity, and HIPAA compliance is built in within AWS for all your healthcare data. All right, so this is crucial for any healthcare company that handles sensitive data like patient information under those strict regulations like HIPAA. All right. Why are the others incorrect? Companies' data is only used to improve. All right, that's incorrect. It's false. It's incorrect. It's just incorrect. Companies' data is not used to improve foundation models. However, it is also shared with. All right. Okay. That's incorrect. And the company's data is used to improve foundation models and is also shared. That's incorrect on both ways. All right. So it just flips and reverses one or both parts. All right. Next question. All right. A retail company is using Bedrock to enhance its product recommendation system with Gen AI. To tailor the AI model to the company's specific needs, the data science team is exploring different model customization methods, since understanding the valid customization options available for Bedrock is crucial for optimizing the model's performance. All right. Fine tuning and continued pre training. Why are these correct? All right. So Bedrock involves changing the model's weights through further training. The two valid methods are fine tuning. This is using label data for like inputs and outputs. This trains the model. This trains the model to improve the performance on specific tasks, and it adjusts the model's parameters based on training examples. And then continued pre-training. So this uses unlabeled data for inputs only and exposes the model to domain-specific topics, improves the model's domain knowledge, and can retrain with more data as it becomes available. All right, so all right, I'll say these ones. Zero shot and chain of thought. All right, these are prompt engineering techniques, not model customization methods. And then RAG, retrieval augmented generation. So this is not a model customization method. It's a technique for incorporating external knowledge without changing the model weights. All right. And we are done for this section. All right. Thank you for joining me. We will try and have another one. But outside of that, I hope you enjoyed this. I hope you learned something. Leave a comment. But before you take the AWS AI Practitioner, go over this, go over your own notes. Good luck. But before we leave, remember to like, subscribe, share this with someone you know who's taking the AI Practitioner exam. Have a good day, and thank you.